Okay, here I am to explain you some more answers that we recorded in solution of worksheet part 3 on Python Basic. I would mainly like to discuss one of the questions. Let me share my screen at first. Um, this particular question, look at this. There was a set A and you equated B to A. That means B will become exactly similar to the set A. Now the first element, look at this carefully, first element of A is changed. That means this 5 is changed to 9. So list is a mutable type. We can individually change an element. There is nothing wrong in it. So if I print A, now instead of obviously 157, 197 will be printed. But the question is, what will be the output of the code given above? What happens to B? That is the most interesting thing that we need to observe here. I guess I discussed that in class 11. Look at this. I had already started writing the same thing. I wrote k equal to 137 and I made p equal to k. So p should be also 137. Now I'm changing k1 to 9. So as a result, the middle element 3 will be replaced by 9. So when I printed k, I got 197. But what's the peculiarity is that if you print P, okay, which was equated earlier, that also got the same change. How is it possible? Because we equated P equal to K before we brought about the change in the first element of K. When we got the change, that time P was nowhere in the picture. P equal to K happened earlier. So we need to understand this concept very, very clearly. What exactly happens when you're writing P equal to K? Basically what is happening is the value, that is 137, P is equal to, the K equal to what? Is 1, 3 and 7. So it's a list, tuple, anything that you call, that is a value. Value has to be stored in memory location. And we know that all memory locations have their unique address. So what happens when you are storing k equal to 137, a particular group of cells, a few group of cells are allocated, and they uniformly will carry a memory address. Okay, they will be we call it referencing. Okay, where that list will be found? The list will be found in a particular address. Now that particular address may be made up of a lot of other small cells, but altogether they will be assigned a common address by the Python compiler. So what will happen is the K being a list, will have a fixed address. Now when you're writing P equal to K, what will happen? P will be just another name, you can say alias, another name for that same location. Two different locations are not being created. Value 137 are stored in a memory location. The same memory location once we named by P, and the same location again named by K. So basically the same memory location has been referenced by two different names. One is P, another is K. So when you brought about the change in the memory location, obviously it will affect both P and K, right? It doesn't matter you write K equal to 1 equal to 9, since P and K are basically the same cell. So the change will be observed if we print P also. Now the second part of the question says that we observed a change here. You found a problem. Which problem did you observe while computing the code? And how can you resist that from happening? Now look at this. I will show you the same code in a slightly different way, and there this thing will not happen. Okay, imagine now my K is equal to same that 137, right? But now I did not write P equal to K. What I wrote P equal to list function. You know, list function is used to bring out a list from a sequence. So who is the sequence? Sequence is K itself. Now in this case, P is not equal to K exactly. Here we are saying that P should be a list which will be developed from the sequence K. Now K may be a list, K may be a tuple. You know that from tuple also we can make a list. So P is a list, K is a list here, or K is a tuple, or K is whatever. That's not the point here. The point is I applied list function on it. Okay, to bring out a meaning out of it so that another list can be formed, right? So in this case, what's happening is P and K will be two different memory locations. That means 137, okay, which was the value of K, that will be stored in a memory location. And when you are writing P equal to list K, another memory location is formed. Another memory location is used where 137 will be stored, and that will be named by P. That means in this case, there are two different memory locations. Value stored in those memory locations are same. That is the list having three elements, 137, but they are named separately. One is P, another is K. In this case, if you bring about a change, like the earlier case, if I write K equal to 1, K1 equal to 9, and if we print K, the change will be there, but the same change will not be observed if we print P. P will remain same. So it is quite obvious that in one memory location we brought about the change in the value, but in the other memory location we did not bring about the change. Okay, that is one of the peculiarity in this question. Another question which some of you made mistakes. Here it is, look at this, the slicing. Okay, slicing, I will tell you one simple thing to remember that will probably help you remember the facts. Okay, what was our thing? The thing was 4, 5, 6, 7, 8, 9. So I will also write the same thing. Okay, say K equal to 4, 5, 6, 7, 8, and 9. Now the slice was like this. It was K, it was blank 3 and minus 1. That was the slice given to us. Let us verify. It was blank 3 and minus 1. Now when there are three items here, when there are two items, you know it very well what to do. Like 2 to 5, you know it very well. Two items means we are talking about second element and we are moving towards the fifth element. In this case, always remember slicing or movement of the, our movement, traversing through the list will be from left to right. Okay, when there are only two elements given here or two numbers given here. One is the beginning position, one is last one, and second one is the end position. But the moment you add the third item here and you write -1, okay, that means the traversing is happening in the reverse direction. That is called from right to left we are moving. The moment you put here -1, remember movement will be from right to left. So when we wrote here blank and we wrote here 3 as given in the question and we wrote here -1, it means that we are moving in the opposite direction. Okay, and we are going towards, beginning position is not known to us. Beginning position is not known to us means we let's keep a hold on it, but we are going towards the number 3, position number 3. So look at this, 0, 1, 2, 3. So we know whatever we mention here, we stop one step before that. Now my direction of movement is from here, like the way my cursor is moving. And no start point is mentioned. No start point is mentioned means here the start point will be the last element. Why? Because my movement, my direction of movement is from right to left. So what will happen? 9 will be the first element. And since the end point is 3, so it will stop one step before the one place before the third position or third index. And as a result, we will get 9 and 8. The explanation is this -1. This -1 is making our movement from right to left. No beginning index is mentioned. So beginning index has to be the last. Okay, because our movement starts from right. That is why it is last, beginning index. And my end position is 3. So it finishes one step before that. So as a result, we get 9 and 8. Because first is 9 as we move from right to left. And then comes 8. Now, exactly, though it was not asked in the question, but I'm showing you the similar thing once again. Okay, if I try to do K, now let's do the opposite thing. Like I wrote 3 blank and then -1. So it means again I'm moving in the other direction. Now my start position is 3. So 0, 1, 2, 3. Start position is 3. And end position is not mentioned. End position is not mentioned means it will take everything. And my movement is, direction of movement is from right to left. So as a result, look at this, what is happening. It is taking from the 0, 1, 2, 3. So first it took 7, then 6, then 5, then 4. As the end position is not mentioned, so that means entire, in the direction of your movement, all the elements, right? So that is how we get this kind of output. So this is a small explanation for you. I hope it will help you. Remaining of the questions, I believe, were simple, and most of you will manage solving it. There should not be any problem. Um, One small thing I would like to mention, this also probably we have done in class 11, long time back. Give one example each of syntax error, logical error, runtime error. Syntax error, you all know that any kind of syntactical mistake that comes under the syntax error. Nothing so great about it. Logical error, try to remember when it's not a syntactical error, not even runtime error. It is a perfectly operable program or code, but which gives you trouble in some way, and it's very obvious that you have applied a wrong logic to compute it. So here I would suggest you, there could be many examples, but from your syllabus, if you see infinite loop, any case of infinite loop will be a perfect example. Infinite loop, you all know, I have given in the solution also, with a for loop, with while loop, with anything you can make an infinite loop. And runtime error means, again, logically it is not wrong. Okay, there is no logical error in it. The program will come to an end. Okay, but it will not give us any kind of output, and rather will show an error. That is a runtime error. Like some of you wrote, an attempt is made to divide a number by 0. We know that we cannot divide a number by 0. So it is undefined and it gives divide error. In fact, if you remember in my previous video, yesterday's video, I was talking about mean, median, mode. Okay, there we saw that mode means the number which most of the time occurs, right? But if there is a mode taken in a wrong, I mean, if the elements are taken in a slightly wrong way, then mode function sometimes gives error. That I was showing you, if you remember. So if I do look at this, those of you who wrote divided, you are absolutely correct. There is nothing wrong in it. But I'm just showing you a slightly different thing, right? Say there is the list here, k equal to 12, 13, then 12, 13, 1 second, 14. So here we can see, we cannot say 12 is the mode, 13 also as a mode, because both appears, the same number of times, that is twice. So in this case, if you use the function, mode function, statistics, if we write, and then mode is applied on the sequence k, look at this, it gives an error, no unique mode. So this also can be called a runtime error, because here logically nothing is wrong, but computation problem came. So any kind of exception, I think exception would be the correct word you can write. Any kind of exception, that means the error that we face while running the program, that comes under the runtime error. Okay, just another example, other than divide error, I just wanted to show you. Fine.